Hi guys, welcome to part 2 of proving that the angle at the center is twice the angle at the circumference. So we are doing the second variation of the theorem, and now the situation is different. We have angle C and angle D that we need to prove that angle at C at the angle at D is twice the angle at C. And if you look at it, the conditions stay the same. We investigated the size of angle C and we found it's 38,08 degrees, and we measured the angle D and we found it's 76,16 degrees, and we multiplied angle C and it gave us that, okay, if angle C multiplied by 2 is equal to angle D, so meaning that angle D is twice the angle C. So now we want to prove that algebraically. So I'm just gonna use a lot of colors here because what we have to do is very tricky. And so first things, the construction. So I want to construct a line joining D and C and produce it to E, thus creating an exterior angle. But now I have two triangles here. I have a triangle DAC and I have triangle DBC. So now the exterior angle of triangle DAC is going to be my D1. That is my exterior angle, right, of triangle DAC. And then I have another triangle DBC. Now the exterior angle of DBC is going to be more than D1 and it's going to be like this. So that will be my D2. And then over here I have two angles. So I have an angle C1 here, that is my C1, and C2 extends all the way here. So now how do I write out the proofs? So to start off, in the triangle D, let me just say wow, my handwriting. Let me just fix my handwriting for a moment. I want you to see this. In triangle, wow, nice. In triangle DAC. So we're in this 1, 2, 3 triangle. We have an exterior angle, which is D1. And we said that in the previous video that the exterior angle of a triangle is equal to the sum of the interior opposites. So it means it is equal to this small angle here, which is C1 plus A here. So it's equal to C1 plus A, right? But and that is the exterior angle of a triangle is equal to the sum of the interior opposite. That is exterior angle. Fine. So now another thing is that DC is equal to AD. Therefore, C1 is equal to A, and it's because oh, let me just write it the way it is. Let me not get ahead of myself. So now DC is equal to AD, and it's because they are radii. They are radii, right? And then it means that A is equal to C1, and it's because angles opposite equal sides. So angles opposite equal sides. Therefore, D1 now D1 is equal to, because A is C1, then it's gonna be C1 plus C1, which is twice of C1. Fine. And then in the next triangle, in triangle DBC, in triangle DBC, the bigger angle, remember triangle DBC, let me just highlight it here. Triangle DBC, here's triangle DBC, and the exterior angle is D2, the bigger angle. So in DBC, D2 is equal to so C2, remember, is the bigger angle in triangle DBC. It's equal to C2 plus B, right? But now DC, exterior angle of a triangle, exterior angle, why am I putting S? So that is the exterior angle of a triangle, right? Here's my triangle. I don't know what is happening with, I think my what's this, my computer wants to, let me just pause here. Okay, here we go. I think my computer wanted to update, or it was updating, so let me just continue. Exterior angle of a triangle. Fine. So now I lost my train of thought there. So far we've discovered that, okay, in the first triangle we had exterior angle is equal to the sum of the interior opposite, and then we had radii, which created angles opposite equal sides, right? Just bear with me, and I'm trying to, okay, fine. Now we have D2 is equal to C2 plus B, which is exterior angle of a triangle. And then also we know that DC is equal to DB because they are radii, right? Then it means that C2 is equal to B because of angles opposite equal sides. So angles opposite equal sides. So we're almost there. We're almost there. So we're almost there. Therefore, D2 now is equal to, because B is equal to C2, then D2 is equal to 2 times C2, because it's going to be C2 plus C2. Fine. Then now we look at the angle at the center, because it's neither D1 or D2. But for us to find the angle here, we can take the bigger angle, right, and subtract the smaller angle from the bigger angle and get the angle at the center, right? So now it means that the angle at the center is D2 minus D1, and that is the angle at the center, right, which is equal to, remember D2, we said D2 is twice C2, right? And then we said that there's a minus. We said D1 is equal to twice C1. Then we can factorize the 2 here. C2 minus C1. And if we look at it, the bigger triangle is C2 minus C1, we get the smaller angle. So the bigger angle is C2 minus C1, which is the smaller angle, and then we get the angle at the circumference. So still the angle at the center is twice the angle at the circumference using the exterior angle and angles opposite equal sides. So I hope that was clarified, and please do like, comment and subscribe for more videos.